This is lesson 1 of topic 9, redox processes, and we will be looking at the definitions of oxidation and reduction. There's 3 ways in which we can define oxidation and reduction, and the first one is in terms of hydrogen and oxygen transfer. If we observe this reaction, we will see that ethanol over there accepts an oxygen or reacts with an oxygen atom to produce an ethanol molecule and water. Now what changed? If we look here, C2H5OH, we had 5 hydrogens plus another one, 6 in total, 2 carbons and 1 oxygen. On the other side, we've got 2 carbons, 4 hydrogens and 1 oxygen. So our carbons and oxygens are the same, but we have lost a hydrogen. And therefore, our first definition of oxidation is it's the loss of hydrogen, or it could also be defined as the gain of oxygen. If we observe a second reaction, we will see that this species over here has 2 oxygen atoms, whilst on the product side, it has been replaced with 2 hydrogen atoms. So in other words, here we have the gain of hydrogens or the loss of oxygen atoms. Therefore, reduction is then defined as the gain of hydrogen or the loss of oxygen. Moving on to our second definition of oxidation and reduction, it is in terms of electron transfer. Now, I want you to recall the reaction you did as a practical in Miss Halp's class, where you had zinc metal reacting with a copper solution to produce zinc ions and copper metal. Now, in this reaction, if we observe the change of charge of the species involved, here zinc is in its elemental form, therefore its charge is 0. On the other side, its charge becomes +2, whilst copper is +2 here and it becomes 0 on the product side. So what happened? For the zinc to go from 0 to +2, the copper ion to go from +2 to 0, there must be an exchange of electrons taking place. The zinc to go from 0 to +2 must be losing 2 electrons, whilst the copper ion going from +2 to 0 must be gaining 2 electrons. Our next definitions then of oxidation and reduction is then as follows. Zinc, which becomes a zinc 2+ ion by giving away 2 electrons, which effectively loses 2 electrons, we say is oxidized, because oxidation is defined as the loss of electrons. Zinc is oxidized. The copper 2 ion, which gains 2 electrons to form the copper solid, we say is reduced, and reduction is subsequently defined as the gain of electrons. Now, in terms of this reaction, we also get 2 terms that are very important that we distinguish them from oxidation and reduction, and students often confuse them. So make sure that you understand the difference. We talk about oxidizing and reducing agents. Now, if you're an agent for something, you're working for that company. So in terms of oxidizing agent, it's an agent for oxidation. So in other words, oxidizing agents are defined as species that oxidize other species and in the process are reduced themselves. An oxidizing agent takes electrons away from something. If we observe our reaction here, the zinc lost 2 electrons, whilst the copper 2+ ion gained 2 electrons. So that loss of electrons by the zinc was facilitated by the copper ion accepting those 2 electrons. So in other words, the copper ion that accepts electrons makes oxidation of zinc possible. So therefore we can say the copper ion is our oxidizing agent in this reaction. Similarly, our zinc, which gives away its electrons to the copper ion is an agent for reduction. It makes reduction possible. And therefore, we now meet the definition of a reducing agent as species that reduce other species and in the process are themselves oxidized. A reducing agent gives electrons to something. The zinc gave electrons away. So in other words, zinc is our reducing agent in this example. We will be looking at a practical of this reaction in the second video in this series. Our final definition of oxidation and reduction is in terms of oxidation number. Now, once again observing the zinc copper 2 plus reaction, we can assign oxidation numbers. Now, you might be wondering, what is oxidation number and why do we use it? Now, first of all, it's important that you note that it's entirely a conceptual thing. So we came up with it as humans, but it is useful. In the process of oxidation numbers, we assume that all species, regardless of their bonding model, are ionic. So even though this is metal zinc, we will assume that it is ionic. But as it's a single atom there with no charge, we can assign an oxidation number of 0. For the copper 2 ion, it has a charge of 2 plus. So in other words, we can say its oxidation number is plus 2. Please note that charge you will write 2 plus, whilst oxidation number you will write plus 2. Subsequently, the zinc ion on the product side has a charge of 2 plus, so the oxidation number is plus 2. And the copper metal is in its elemental form, so it has an oxidation number of 0. In other words, what we have here is that the zinc has an oxidation number of 0, which increases to plus 2, whilst the copper ion has an oxidation number of plus 2, which decreases to 0 as it becomes elemental copper. So in other words, if we define oxidation and reduction in terms of oxidation number, we will define oxidation as an increase in oxidation number. That is what happened with the zinc, whilst reduction will be defined as a decrease in oxidation number, which is what happened to the copper 2 ion. In summary, we thus have 3 definitions for oxidation and reduction. Oxidation can be defined as the loss of hydrogen or the gain of oxygen. It can also be defined as the loss of electrons or an increase in oxidation number. Reduction can be defined as the gain of hydrogen or the loss of oxygen, the gain of electrons, or a decrease in oxidation number. We also get the terms oxidizing and reducing agent. An oxidizing agent oxidizes other species and is reduced itself. It takes away electrons from something. A reducing agent reduces other species and is oxidized themselves, and it gives electrons to something. This then is the end of lesson 1 on topic 9, redox processes.